Good afternoon. Today we are going to study about earthquake. Okay. So, the first thing we have to learn is what is earthquake, right. So, before getting deeper into it, we have to understand the definition of earthquake. So, earthquake comes from two words, earth and quake. Okay. So, here we understand what is earth, we have to understand what is a quake. So, quake here refers to motion or tremor or vibration or oscillation, right. So, whenever a particular portion of the earth's surface, they undergo a kind of motion or a tremor or vibration and oscillation, we call it as a earthquake. Now, we have to understand what are the reason behind such quakes or what are the reason behind such motions that takes place on the earth's surface. So, the causes are the following. Number one is volcanicity. So, what is a volcanicity? Volcanicity here refers to the entire process that is involved during the process of volcanic eruptions. So, often volcanic eruption and earthquake are said to be cause and effect, because many occasion it has been noticed that earthquake is followed by volcanic eruptions and volcanic eruption is followed by earthquake. So, whenever there is a volcanic eruptions, not necessarily always, but whenever there is a volcanic eruption, the molten matters, they rush out from the interior to the surface with a violent speed, breaking open the crust, and this sometimes cause tremor in the nearby region, leading to earthquake. And the next causes is faulting or elastic rebound theory. Okay. First of all, we have to understand what is faulting. Faulting is dislocation of a particular portion of the crust. So, it may be horizontal, it may be vertical, or it may be transformed. So, faulting many often are causes of earthquake. And H.F. Reed, he has developed elastic rebound theory on the basis of this faulting activity. So, according to him, that below the soil there is a layer of rocks which undergoes expansion and contractions during the process of faulting. Okay. So, whenever there is expansion or there is a stretching of this layer, so the rocks are also, they are just like a elastic band, they also get stretched, and there is a constant contraction and expansions during a faulting process. When the elasticity goes beyond the tolerance level of the rocks are broken into pieces. But immediately after, the rocks try to come closer, they try to come to the original position. So, there is expansion and there is a contraction of the layer, and this may lead to an earthquake. The next one is hydrostatic pressure and anthropogenic. So, hydrostatic pressure basically caused by human activities, that is why we use this term anthropogenic. So, whenever there is a massive construction in any crustal part of the earth's surface without proper testing, or we can say that any crust which is weaker in some way, and there has been a massive construction like airstrip or say dam or any kind of or a skyscraper, these may lead to hydrostatic pressure on the surface, and these may cause earthquake. Example is Koyna earthquake of 1967 that occurred in Satara district of Maharashtra, and this earthquake was caused by the Koyna dam that has been there, Koyna dam that has been constructed in those regions. Then the last one, the last but not the least one is plate tectonic theory. So, this plate tectonic requires an entire chapter, but here we can discuss in a nutshell. So, as we all know that the earth's surface is divided into a number of plates, and these plates they move in relation to each other. So, there are basically three types of plates: convergent plate, divergent plate and transform plates, and these plates are many a times responsible for earthquake. The next thing we will learn about some of the important points associated with the earthquake phenomena, that is focus, epicenter, homosysmal lines, seismograph and earthquake shadow. So, we have to understand these points with the help of a diagram. So, we have to understand what is a focus and what is a epicenter. So, what is a focus? Focus is a point that lies below the earth surface, and this is the point where the earthquake originates. And you can see concentric circles. Concentric circles represent the energy that has been released and has been it is being transmitted to the different parts of the crust vertically, horizontally. They are moving out in the form of waves. So, focus is the point one has to remember as the point where the earthquake originates. And here we see epicenter. Epicenter lies just above the focus, and epicenter is the place which experiences the earthquake first. So, here we can see a diagram which has a focus, that is where the earthquake has originated, and the point where the epicenter, this is the point above the surface which is the epicenter, this is the place where the earthquake has reached first, or we can say this is the place which has experienced the earthquake first. And there are concentric circles just beyond the epicenter. So, what these concentric circles refer to, or what this concentric circle represent? These concentric circles, these, for example, the first concentric circle just after the epicenter, it refers to, it consists of number of points, and these points together make a concentric circles. So, what are those points? The points are places, these are lining, actually the concentric circle here refers to line joining places experiencing earthquake at the same time. Okay, so, we have different concentric circles, that means these concentric circles represents places experiencing earthquake at a particular time. It means that earthquake has occurred and then it has transmitted to the epicenter experienced earthquake first, then the next layer, the next concentric circle, these are the places which experienced earthquake just after the epicenter. Likewise, as we move away from the epicenter, the time will vary, the time will be later. So, what is a seismograph? Seismograph is nothing but an instrument that records earthquake intensity. So, we have an diagram, we can understand this with the help of a diagram also. Yes, this is a seismograph and this is the instrument that records the earthquake intensity. Then we have what we have? We have earthquake shadow. So, this point can be discussed in the latter part. Now, scale. So, to understand the intensity of earthquake, so we have two scales basically, prevalent, widely prevalent, that is Mercalli scale and Richter scale. So, Mercalli scale is basically divided into 12 classes and 10 and 11 related to complete devastation. That means, if the scale reaches 10 or 11 points, then that means it is complete devastation. At 12, nothing stands erect, all objects fly towards the sky, very big fissures are caused and great thundering sound is caused. Okay. So, basically Mercalli scale is something, it is very qualitative in nature, and it is very qualitative in nature, and it basically depends on the human experiences. So, as human experiences vary from person to person, so this scale is not very much reliable. So, in that place the most popular one that is presently being used is Richter scale. So, Richter scale is quantitative in nature and it is very scientific, and it has 7 scales. So, the next thing is the seismic waves. So, as I said earlier, whenever there is an earthquake that originates in the focus, so this is transmitted. So, whenever there is an earthquake, energy is released from that focus point, and this energy is transmitted to different parts of horizontally, vertically, it travels in the form of waves and it reaches the surface. So, basically there are 3 types of waves whenever earthquake occurs, and these waves are P waves, S waves and L waves. Okay. So, now let us understand the different types of wave that they generate during an earthquake. The first and foremost wave that originate during an earthquake is a P wave. Okay. So, P waves is alternatively known as primary waves or longitudinal waves or comprehensional waves. Okay. So, this is analogous to sound waves. That means, it is very much similar, the travelling is very much similar with the sound waves, okay, and it moves into a to and fro manner. Okay. We can understand this with the help of a diagram here. So, this is a P wave, and so they move like to and fro. They are very much similar to the sound wave. So, each molecule tries to strike the other molecule like the sound wave does travel. So, this is P waves, and in P waves particles move to and fro from the line of propagations. So, the speed range from 5.4 to 13.08 kilometer per second. It is the fastest among the three. It can travel both in solid and liquid. So, this is one of the major, this is the most prominent, or we can say that extraordinary characteristic of P waves, that it can travel in both solid and liquid. The next wave is the S waves. So, S waves are secondary waves, transfer waves or distortional waves. So, these waves are analogous or similar to water ripples or light waves. Okay. Particles move at right angle to the rays, cannot travel through liquid. The speed is 3.2 to 7.2 kilometer per second. So, here in the diagram we see how the S waves travels. It travels in the form of waves. So, next is, this is, yes, I was talking about the shadow, the earthquake shadow. So, here if this is the epicenter, we can see how the P waves are travelling. The P waves and S waves, they get refracted and reflected every time as they travel on the earth surface. So, we can see how the P and S waves are moving. The S waves represent the black one and the yellow one represent by the P waves. So, here we can see that in the mantle or in the core, the S waves are absent, as the inner core and the mantle regions are molten or liquid form. So, the S waves are absent in this region. So, here you can see a shadow region is formed. What is a shadow? That means these are the regions where earthquake waves are not felt, or the earthquake waves fail to reach. So, this is called this is a shadow, earthquake shadow.